Welcome to the third film in our Walls series, in which we deal with the construction of load-bearing walls. Masonry can be made of natural stone or man-made bricks or blocks. This photograph shows a wall built using both stone and bricks. This is known as mixed masonry. You may remember that this is the first house that my brother and I built. Our client, a demolition contractor, had been collecting quarry stone for years, but did not have sufficient dressed stone to make the window jambs, the sides of the window surrounds. What he did have, however, was a stock of old bricks, so we followed an old Ruhrgebiet tradition and built the window jambs in brick. Man-made bricks and blocks are categorized according to raw material. Bricks are made of clay-bearing mud or loam. As the name suggests, sand-lime bricks are made of a mixture of sand and lime. Concrete blocks are made of concrete, that is, cement and aggregates. Concrete blocks are divided into various subcategories. You may already have heard of aerated or porous concrete. It's a type of concrete containing small air voids that make the blocks lighter and improve their thermal insulation properties. Natural stone denotes any type of stone obtained from nature. Today, natural stone is extracted from quarries and industrially processed to produce building products such as slabs or building stone. The natural stone you can see here was quarried and processed locally in Rochlitz, a town in the German state of Saxony. It provided a relatively inexpensive material because rather than specifying the length of the blocks in advance, we simply used them as they came. We saw this type of bond using free brick lengths in the last series. With man-made bricks and blocks in particular, it's the bulk density of the brick or block that determines many of its properties. Bulk density is given in mass per volume. In simple terms, it refers to the porosity of the material, that is, how many tiny air voids it contains. A brick or block with a high bulk density has a relatively low porosity and is therefore heavier, offers better sound insulation, and has a lower compressive strength than one with a low bulk density. The advantage of low bulk density, on the other hand, lies in the poor heat conductivity of the brick or block, or, seen in a positive light, its good thermal insulating properties. Here you can see a low bulk density perforated brick on the left and a sand-lime brick with a high bulk density on the right. Solid load-bearing walls are very often built not of masonry but with concrete. Concrete is produced in a concrete plant, delivered on site in a concrete mixer truck, and poured in a more or less liquid state into formwork in which it then sets or cures by means of a chemical reaction. The formwork, also known as shuttering, can then be removed. Widely used by the Romans, concrete is still made up of cement, stone particles or aggregates, and water, which are bound together during the curing process. If you add so-called reinforcement to the concrete, that is, steel bars, mesh or stirrups, the concrete component can absorb tensile forces and thus withstand bending stress. This is known as reinforced concrete. The difficulty in reinforced concrete construction lies in the production of the formwork in which the concrete is to be cast. Concrete workers refer to this process as setting the formwork. This photograph illustrates the standard process for building a concrete wall. On one side, the shuttering is already in place, on the other, the reinforcing bars are being assembled. At the bottom, you can see the connecting bars emerging from a section of the wall that has already been cast. Masonry walls are not particularly suited to absorbing horizontal loads, and where this is necessary, reinforced concrete is used instead. Since the concrete is poured into the formwork, the issue of modular coordination is not relevant here, and concrete components do not have to follow the octametric system. More commonly, wall thicknesses are specified using the decametric system in widths of 20, 30, or more centimeters. Increments of 2 centimeters are standard. In the interest of completeness, I'd also like to mention 2 other materials that can be used to build solid load-bearing walls. Solid timber construction is a relatively new building technique. We use the term solid timber because sheets are glued together in layers or cross-laminated to form large wall or ceiling panels. The vertical joints are the butt joints of the glued sheets. Less frequently, walls are made from rammed earth. Here, the production principle is comparable to that used in concrete construction. The earth is layered in the formwork and rammed down. When the binding or drying process is complete, the formwork is removed. The joints you can see here are what we call construction joints between sections constructed at different times. Summary: load-bearing walls can be made from various materials. Load-bearing walls are often made of reinforced concrete because they absorb horizontal loads better than masonry walls. Load-bearing walls can also be made of solid timber or rammed earth. The fourth film in the Walls series deals with the question of how to make an opening in a load-bearing wall.